All right. Next we have our word problems. More of application problems. First one, and this is gonna be dealing with IQ scores for the very couple examples. The first 6 examples, 5 examples are gonna be dealing with IQ scores. So you have on number one, it says that the IQ scores are normally distributed with a mean of 100 and a standard deviation of 16. Determine the percentage of people who have IQs between 115 and 140. So you're going to have to convert 115 and 140 to z-scores. Because if you remember, this Bayes only consists of numbers between -4 and +4. So any real life number has to be converted to a z-score to fit onto the Bayes. Okay? So that's going to be our very first step, is changing 115 and 140 to actual z-scores. So the formula for changing to z-scores is x minus the mean divided by the standard deviation. And you know my symbol sometimes looks a little weird, but that's standard deviation. So if we're going to convert 115, any number you're converting is represented as x. So we're going to say 115 minus 100 divided by 16. That's our standard deviation. So when you subtract 115 minus 100, that gives you 15 over 16, which divides to be 0.9375. Now, if you notice with your table, the z-score column lets you know that you only have 2 numbers behind the decimal, okay, for z-scores. For areas, you have 4 numbers behind the decimal. So round 2 numbers, okay, for z-scores. So 7 makes that 3 become a 4. So we have 0.94 is the corresponding z-score for 115. We're going to convert 140 to a z-score. So 140 minus 100 obviously is 40 divided by 16. We get 2.5 evenly. So 2.5 will be the corresponding z-score for 140. Okay? So what I just did was convert 115 and 140 to z-scores to fit on the actual Bayes. Okay? Now, I'm going to shade my Bayes. Well, I've already shaded it for you to show you what I'm asking. Okay. Now, if you look at the Bayes, I have a lot going on. I hope you can see the line, the z-score number line. 0 represents the middle, which also is where the mean lives. And then the z-score for 115 is 0.94, and the z-score for 140 is 2.5. So I wrote the real actual number line underneath it so you can see the corresponding z-score with its actual number, okay? Now, the shade that you're looking for, the area of the shade that you are looking for is in purple, okay? That's the shade. I want to know between 115 and 140. That's the purple shade, okay? Now, that shade is not directly on this table, all right? It's not directly on this table. This table has 3 types of shades on it: body, tail, and portion between mean and z. So since this actual shade is not directly on this table, then we're going to have to do a little math to find that shade, okay? Now, this problem will correspond to the problem in my labs that I put on 6.1, 6.2 homework, number 9. This is the type of shade that was given, okay? So you might want to make sure you take notes so you can work that problem. But I'm going to use the portion between mean and z measurement to help work this problem. And the reason, because it's more closely a fit to that one than a body or a tail. The body, it doesn't never cross over the middle. And then the tail is not all the way at the end. So it's not those two measurements, but I can see portion between mean and z very easily. Now, I want you to make sure you understand this point of what I'm trying to show. I need to know what's in purple, but that measurement is not directly on the chart. But I do know on the chart, I can find the measurement between mean and z of 2.5. The measurement between the mean and z of 2.5 would consist of what I need and what I don't need. I don't need that green piece, okay? However, though, that's a measurement between mean and z for 0.94. That's on your chart. So I can go on my chart and find that green piece. That would be the mean and z measurement for 0.94. However, I don't need it though. I can go find between mean and z of 2.5. But that measurement is going to include what I need and what I don't need. That's what the blue line going across represents. If I go do mean and z of 2.5, it's going to give me what's in purple and what's in green. So it makes sense to me that if I go get that number and then go get the green measurement, which would be the mean and z of 0.94, and subtract the two. Because if I subtract that green piece off, I'm going to be left with what's in purple. Okay? So I hope you heard that. I'm going to go get the mean and z measurement for 2.5 and subtract the mean and z measurement of 0.94 off of it. And that's going to give me what's left in purple. So let's look at those measurements. Okay. So, .5, so you won't get confused, and this will represent the mean and z measurement. So 2.5's mean and z measurement is 0.4938. 0.94's mean and z measurement is 0.3264. So I'm going to take the measurement that includes the green and the purple and subtract off the green, and I will be left with what I need in purple. And that would give us 0.1674. So the purple measurement is 0.1674. That's how much it measures. Now the question said, give me the percentage. So this is decimal form. So to give the percent, you would simply move the decimal 2 places to the right, keep all numbers, and you would have 16.74%. That would answer your question. So the question was, what's the percentage of people who have an IQ score between 115 and 140? 16.74%. Okay, let's go to number 2 for more examples. Number 2 It says, use the same mean of 100 and standard deviation of 16. Determine the percentage of people who have IQs between 120 and 145. So again, I need to convert 120 and 145 to z-scores. So we're going to say 120 minus 100 divided by 16. That would give us 1.25. Then we're going to convert 145 minus 100 divided by 16. That would give 2.8125. And keep in mind, z-scores, you need two numbers. So the 2 makes the 1 stay a 1. So that corresponding z-score would be 2.81. Okay. Now, it's kind of the same setup as number 1. I'm going to zoom in. On the bell. Now, I want to know the red shading. That would be the people who have an IQ between 120 and 145. You see I have the corresponding z-scores, 1.25 and 2.81. So I want to know that red piece. So I can go and do the whole mean and z subtraction deal to get what I need, because I can find the blue piece. That would be the mean and z between 0 and 1.25. That I don't need though. I can go do the mean and z for 2.81. That's going to include the blue and the red. That's why I got that purple line going across both pieces. But if I go subtract the blue off of it, I'll have the red piece, what I need. So again, we're going to subtract the mean and z's. Okay? So we're going to go and get the measurement. Okay. So for 2.81, his measurement between mean and z would be 0.4975. And then 1.25's measurement between mean and z would be 0.3944. And again, I'll subtract the two measurements. That would give me 0.1031. So that would be the actual measurement for the red piece. But I want to know it in percent form. So that would be 10.31%. Move the decimal 2 places to the right. Okay, let's look at the next one. Number 3. Number 3 says, using the same mean of 100 and standard deviation of 16, determine the percentage of people who have IQs between 100 and 130. Now, I hope you notice that your start, 100, is the middle. That's your mean. 100 is your mean. So I'm asking you to go from the mean to a whole nother z-score. So I really don't need to convert 100. Because if you convert 100 you're going to have the mean and the z that you're converting the same number. If you convert it, you're going to get 0 because 100 minus 100 is 0. So I'm hoping that would tie to the reason why we're starting directly in the middle. I'm going to convert 130 though. So 130 minus 100 divided by 16. And that would give us 1.875. And keep in mind, z-scores, you need 2 decimals. So 5 would make that 7 become an 8. And I have 1.88. Okay? So now, if you look at your bell, if you look directly at your bell, and I'm going to try to zoom in on the bell. Ooh, sorry about that. I'm asking you to go from 0 to 1.88, from the middle to directly to a Z. There's not a piece that you don't need that's shaded. You know this is directly on the table. This is a clean between mean and Z shading. Your mean is 100. You're starting at 100. And I'm going to 1.88. So that's on your chart. So you just need to go look for the mean and z-score for 1.88. And you will find that the measurement is going to be 0.4699. And that would be 46.99%. There's no subtracting to do on this problem. That's a direct portion between mean and z.